Welcome to Foundation Python Day 2 Variables and Data Type. Any language we try to learn, whether it's C, C++, Java, Spark, SQL, anything, what we try to first understand is the variables and data types that are possible in it. So, therefore, while learning Python, let's take a deep dive into what all common variables are there, and in the context of data engineering, what all variables we use in Python. When we begin learning Python, our first goal isn't to memorize the syntax, it's to learn how to think in terms of data. Every program we will write, whether it's cleaning millions of rows in data lake or loading AP or loading them into a warehouse, begins with a simple idea: storing something, name it meaningfully and use it purposefully. Storing that data at certain place is very important in data management. That's why variables are very important and data types we need to learn. Variables, naming the data you work with. We start naming the data. Okay, naming the data helps us understand how we are processing it. A variable is like a labeled container. I always imagine it like a box. Okay, and in that box certain things are present. So like that, variable is like a labeled container on the data engineer's workbench. You decide what to store in it: a number, a name, a list, or a table. Python remembers it for you. So on the similar line, let me start the cluster in the meantime. This is my Databricks free environment, and within that I put some exercises for Python. So this is my first exercise in which I am defining some variables in Python. In Python, while defining the variable, there is no need to name it like a var or something, right? The way we do in C, C++, or Java, maybe. We don't have to do it. So we just name the variable. This is a variable, and whatever is it that we try to store, Python try to gauge the data type of it, and it will automatically uh, assign the data type to that variable. So, for example, company name, we are storing a string. For num employees, we are storing a number. For revenue in billions, we are storing a float, like that, right? And then is partner with, I'm storing something like true or false. It's a boolean. So this way, we can define the variables. Each of these tiny unit of memory is holding some data. Notice how the natural naming feels. Company name, right? Company name. So num employees, revenue in millions, like that, right? So good naming convention is the first sign of thoughtful engineer. This is a very important statement. I have seen, I work with multiple engineer on a day-to-day basis. I go for the reviews of their code, and I just get amazed. Means amazed in a very wrong way, because they don't know how to put the right variable names to the variables. Because see, what happens in an organization is, people keep on writing the code, and code is not written in a single day. It There are years that code is getting maintained. For example, if I once joined a team, and that code was getting written from last 10 years. So imagine the fact, such code is there and we have to do an enhancement in it, or like build something new out of that, and people start giving the name of the variables like var1, var2, var3. Compare it with the best practice that if you name it as num employees, the variable name itself tells me what might be present in it, a number that is related to employees. Similarly, company name. It is so easy to gauge, right, that a company name would be present, and definitely a company name is a string. Therefore, a string must be present, right? So this easy it has to become. So as I always say, it is very difficult to do simple things. It is very difficult to do simple thing. That is definitely true in case of naming a variable. A good programmer gives a right name to a variable. Okay, so name a variable very good. Otherwise, it become a maintenance havoc. Moving to data type, the nature of the value inside. So the container, we said, right, a variable is a container, and what is present inside the container, the nature is defined by the data type. So every variable has a type, just like every column in a database table. If you ever seen a schema like this, you already understand data types. They describe which kind of data lives in each variable, as I mentioned, right? So let's begin with our first one, which is integers. Int, correct? Whole numbers, no decimals. Whole numbers, nothing after a decimal point. So for example, order count. This is a good naming convention, right? Order count, year. This is all a whole number. Have you ever seen an year which is 2025.1? No. So you'd always know that an year is an integer. So this way, it is there. And you can there is something in Python called type. So let's say you define a variable order count, and you can just simply do a print. A print in Python works like print. Print is a function. So inside that you can put like type of that variable, and you can see the variable, right? The next set of variables that we are going to see is a floating point number. Now there will be values which has a significance after decimal point. For example, average order value or a discount rate will always have something after decimal as well. So let's say if you have a discount of, let's say you have discount of 20.25%, right? And then you define it as an integer, then it will lose that 0.25 value. So then it become essential to name it as a floating point number, and therefore we have named it as a floating point number. We are just like, let's say, defining it, and then we'll just print the type of it. Okay. Now one important thing that you would see is, if you mix the integer and float in an expression, for example, this average order count, I think, just let me just check. Yeah, order count is an integer, and average value is a float, correct? Average order value is a float, and average order value into order count, let's say, is a formula. Order count into average order value is something that gives you a total revenue. What happens when you mix the two data types together? If you do such a thing in any other language like C++ or Java, it would give an error, because it will say that the data type of the two variables that you are doing some operation is not same. You need to bring it into a same type, and then you would have to multiply. But Python do no such things. In If you mix integer and float in an expression, Python automatically promotes the result to a float. So Python would automatically find the result. It will understand that a float number is getting multiplied, so answer is definitely going to be float. So it will not use integer, but it would convert it into a float. That is what I have shown. So even if the answer is like 29490.0, it is or defined as a type of float, so that the value after decimal is not lost. This is the beauty of Python, and we definitely need so many such facilities when we define the data pipeline. And that is again another reason Python is a beautiful language for doing data engineering. Moving to next data type, string. This is an extremely critical data type, because whenever you are acquiring the data, ingestion happens. What is happening is, let's say you have IoT sensor devices all over the place, right? And they are sending you the data. How they are going to send the data? Most of the time the data is sent in a serialized format. When I say serialized, the data is sent as a binary digits, and then it is recompiled and given back to you. So therefore most of the time what happen is that data type is not present, because it is very difficult to send the typed data, because sensors are sending that data, right? They can send a value like 4.2, but they can't send like, okay, 4.2 is a float. They don't send it. And there are many such practical scenarios where if you have to send the data faster, you definitely have to serialize it and send it over the wire. We call it as over the wire. So therefore, whenever you are building a data system and you are ingesting the data, 99.99% of the time you will receive it as a string. You will never receive it as a typed value. 99.99% of the time, because sending a typed value require a lot of coordination. And I know there are many places in banks, and whenever we are getting some critical and important data, we definitely ask them to send out a data type as well. But then in these cases, when there are 99.9%, as I mentioned, it is not possible. So they would just try to send a file, or they would just try to send a data. So that's why string is a very critical important structure whenever you get an ingested data. String hold everything inside code in terms. This could be a customer names, categories, and IDs. Let's try this. So this is a customer name. and region. I have defined it, and then let's try to print that out. They are also one of the most common data type in the ETL work. As I mentioned, whenever you are at the ingestion end, you definitely need this data type. Moving to our next data type, which is Boolean. Boolean, again, very important data type present in almost every language. In Python, this is very important to define the control. It is used to uh, not define the control but take the decisions. Okay, so Boolean represent truth values like only true or false. They help you control logic. As I mentioned, they help you to define the controls, control flow, filter data, validate rules. So there are two types of this such available. Giving the right name to a boolean is very important uh, work in building Python code. See this one of the variable name that I have given, right, is active customer. This is so much of a representative of what must be present inside it. Is active customer, it must be either true or false. So definitely its data type is boolean. And is active customer is, if the customer is active it is going to be true, and if it is not then it is going to be false. It's so much of a very easy to understand all these things, right? So you will use booleans exclusively while building conditions and data quality checks in data engineering world. List. List is an ordered collection of item. Imagine to-do list or queue of data sets. Process that list feels like. List is a very critical data type in data engineering because you will not get the data in just like singularity. They will exist in multiple chain of values and all, right? So in such cases, list play a very critical role. So for example, countries, you can define multiple countries as an array, and then you can simply print it out. Python lists are mutable, meaning you can add and remove elements. So PySpark list, unlike the Spark list, Spark is definitely not a mutable because Spark is built out of Java. So Java objects are immutable, so it follows that culture. But Python lists are immutable. You can very easily manipulate. You can very easily add or remove elements from the list. So they are mutable. You can mutate it. Tuples are the list but immutable. Tuples, with their immutable nature, they help you. They keep your constants safe from accidental modification. They are mostly used to define the constants. Okay, almost similar to list, but there is one difference. So, for example, lists are defined like with square brackets, but tuples are defined with the round brackets. That way, you can very easily understand that whether you are defining a list or tuple. The main difference between list and tuple is list is mutable, but tuples are immutable. Okay, and therefore their use also varies. This is another important data type, which is dictionaries. Dictionaries store the key value pairs like a small lookup table or a configuration map. So simply they can store uh, the key value pairs. Key value pairs are very important in case of data engineering. There is one statement which I have written. Let me just read that out for you. In data engineering pipeline, dictionaries are often used for holding file mappings. File mappings, right? Holding file mappings is the word. Storing metadata and passing configuration to the function. So whenever you are sending a configuration, you need to send two values, key and value. So all those places dictionaries are used. How it is defined? So you can put a brace bracket like this, and within that brace bracket, you can put like key and values which are comma separated. Key value, key value, key value, key value, like this. You can just simply run it. It will define the dictionary customer. So customer has like multiple properties. Customer has ID, customer has name, customer has city, customer has loyalty points, and they can be grouped together to form as a dictionary. They are incredibly useful when working with structured or JSON like data. JSON is another important uh, data file type rather. um, Within data engineering we'll learn that it is JSON is very critical for any kind of API or logging or any kind of such stuff. It's an unstructured data, it's a semi structured data type. We learn it soon. In few of the lectures we are having a dedicated lecture for JSON handling. Okay, so like that we'll do it. But yeah, as I mentioned, understanding dictionary is very critical. So whenever you are doing mappings, metadata, and passing configuration, you should use the dictionary. Okay, sets are unordered collection of unique element. They help you find distinct values or eliminate duplicates. So they are the distinct values. Simple example is, let's say you define these customer IDs. Okay, these are the customer IDs that you have: 101, 102, 103. Again you have 101 and 102, but if you give it to a function set, it is going to only keep the distinct values. So it will only keep like these values: 101, 102, and 103. Can simply print it out, and you will appreciate the set when deduplicating IDs or comparing list of values between the system. Why understanding this data type matters: in future, as a data engineer, you will work with structured, unstructured data, often messy, inconsistent, and huge scale of data. Then, first step to taming the chaos is knowing what kind of data is present in it. For example, and what operations are allowed. So, for example, numbers can be aggregated, string can be perform multiple operations, cleaning, splitting, concatenation, all those things are possible. List can be, since they are mutable, you can add or remove elements to them. Dictionaries can be mapped, you can map the dictionaries, and uh, they can help you store the configuration. And sets can be used for deduplication. Only this much section of an understanding will help you in defining and setting up your data pipelines, and help you to achieve your goal of becoming an awesome data engineer. There are some certain exercises which I'll post it in the comment or chat, will help you to uh, try it out yourself. Okay, if you want to understand how I have set this free environment of Databricks, there is a separate video I have put in, and maybe I'll put a link of that video as well. But that you can set this environment up, and I can share these exercises with you, and you can very easily understand variables and data type in Python. Now we'll take this journey ahead, and in day 3 we'll learn operators and expression. Okay, variables are your way of naming the world, and data types are your way of understanding it. You should name it right, and then you should understand what is stored in it. That will help you to become an awesome data engineer. Thank you guys for listening into this patiently. Thanks.